In this question, we're given a time domain signal and it's passed through an ideal bandpass filter. And we're asked for the power of the filtered signal. So in general, if you want to find the power of a signal consisting of sinusoids, you would simply take the amplitudes here, you would square them, divide by 2, and you would add them. So the unfiltered power is simply 2 squared over 2 plus 8 squared over 2 plus 8 squared over 2. But they're being passed through a bandpass filter, so some or all of these might be blocked by the filter. So let's look at the signal in the frequency domain. So here's our omega in radians per second. And we can put our frequencies. So the coefficient of t, that's omega, so that's your frequency in radians per second. So we've got 685, 310, and 1201. So let's approximate that. So 310, 685, and 1201. So these are my components, and I can put the amplitudes roughly 4 times as big, maybe not as high. There. Okay, so that's a very rough sketch. So now let's look at the low-pass filter. The low-pass filter has cutoff frequencies of 550 and 750. So that would be somewhere here and here. And because it's a band pass filter, it means the pass band would be between these two numbers. So it would pass components between these two and block components outside. So you can probably see already that only one of these 3 components would actually survive the filter. So this component at 685 is in the pass band, so this actually survives. So this is the pass band, and everything above and below will be blocked, will be attenuated by the filter, removed. So the only component that would survive would be the 685. So what we're interested in here is this component. So I would look at the signal and I'd say the filtered signal let's assume that it's an ideal bandpass filter, and therefore it wouldn't change the amplitude or the magnitude there, so it would remain 2 cosine 685t. I mean, in practice, there would always be a change there. But let's assume that that doesn't change. So the power would be half 2 squared. So that's the power of a sine wave. It's the amplitude squared divided by 2. So that's just 2. So that's how you would approach a question like that. You don't have to sketch this, but you need to visualize which of these 3 components falls within the pass band. So we can see that only one falls between the pass band, and you can find the power of that component easily.